What if I told you that the device you're using to watch this video originally was a weapon of war? Not the plastic or the glass, but the very idea of it. Before it was a smartphone, it was a 30-ton beast designed to calculate the path of a missile. Before it was the internet, it was a plan to survive the nuclear winter. Today, we are looking at how humanity's most destructive moments created our most vital technologies. This is the secret history of the digital revolution. In 1940, the Allies had a massive problem, a math bottleneck. In the UK, the Germans were using Enigma machine to scramble orders. There were billions of possible combinations. If you tried to solve it by hand, the war would be over before you finished the first page. Meanwhile, in America, the army was drowning in ballistics. To hit a target miles away, soldiers needed a firing table, which were books of complex maths that took human computers weeks to calculate for just one gun. We didn't just need more soldiers, we needed a machine that could think at the speed of light. To solve this, engineers turned to the vacuum tube. Technically, this is a triode. The main difference between a diode, which you may have heard of, and a triode is the number of electrodes and their ability to control current. The diode is a two-terminal device that allows only electricity to flow in one direction, while a triode has a third electrode that allows it to amplify or switch signals. Now, in a triode, inside a glass bulb, a heated cathode shoots a stream of electrons towards an anode. But there's a control grid in the middle. By applying a tiny voltage to that grid, you can create a choke. You can choke the electron flow or let it pass. This created a high-speed switch with no moving parts. On became 1 and off became 0. By wiring thousands of these together, we created the first logic gates, the physical building blocks of binary math. But how did these tubes process data? Early machines like ENIAC or electronic numerical integrator and computer did not have a RAM or hard drives. They used accumulators. Technically, these were ring counters. If the machine needed to store number 3, it would send 3 electrical pulses to a ring of 10 vacuum tubes, flipping it to the third tube on. To add 2, it sent 2 more pulses. If it had 10, it carried the 1 to the next ring of tubes. These machines were literally counting pulses of light to simulate human arithmetic. Now, consequently, this desperation led to the 2 miracles of engineering. In Britain, Tommy Flowers and Alan Turing built Colossus. It used 1,500 vacuum tubes to perform logic gates. It was the world's first programmable digital machine. In the US, it was ENIAC, which was a 30-ton monster that consumed enough power to dim the lights of an entire neighborhood. How did this help in the war? Colossus allowed the Allies to read Hitler's personal messages, confirming that their D-Day deceptions actually worked. Thousands of lives were saved because a machine solved a puzzle in hours that would have taken humans years. But then the war ended. So, what do you do with a 30-ton calculator? Scientists like John von Neumann realized that these machines weren't just for bombs, they were for data. They identified that if you could change the software without rebuilding the hardware, you could use it for anything. By 1951, we had UNIVAC, which predicted the US election on live TV. Then came Leo, the first business computer used by a tea company to track payroll. The impact? We moved from the industrial age to information age. Every spreadsheet, every bank transfer, and every AI model is a direct descendant of those wartime vacuum tubes. This civilian breakthrough came with the stored program concept. Engineers realized that instructions, the how-to, could be turned into numbers and stored in the memory right alongside the data. Technically, the hardware became a blank slate. The control unit would fetch a number from memory, decode it as a command like add or store, and then execute it. This meant the machine could stay the same while the software changed the task. This flexibility is what allowed a military missile calculator to become a civilian banking system and eventually your smartphone. Now, here is the $64,000 question. Would we have the computer without the war? The objective research says yes, but much later. The theories for computing were actually published in 1936, years before the first shot was fired. Inventors in Germany and US were already building prototypes in their garages. However, war provided a technological pressure cooker. No private company in 1940 was going to spend millions on a logic machine. War provided infinite funding and forced the smartest minds on earth to collaborate, and most importantly, it created a deadline. Without World War II, the computer might have remained a niche laboratory tool for decades. The war didn't invent the digital age, but it accelerated it by an estimation of 20 years. It's a strange paradox. Our most brilliant tools for connection were born from our greatest periods of conflict. Next time you check your GPS or send an email, remember you're using the legacy of a secret war. What other war tech do you use every day? Let us know in your comments. Thanks for watching.